All right, so we're going to start with 5.2, the natural logarithm with integration. So this is a rule you have seen, but you've seen it written in reverse. We had a derivative, or we had a function f of x equals ln x. We took its derivative, and it was 1 over x, and we spent a whole section 5.1 talking about that rule, right? Yes, we did. So that produces the following integration rule. If we have the function 1 over x, and we want to know what is its antiderivative is ln. And all of a sudden, you see something we saw in the last section as well, absolute value of x. What am I missing right now? Plus the c. So we have the antiderivative of 1 over x is ln of the absolute value of x plus c. And what we're going to be doing in this section is applying that rule. So here's a real quick and easy one. What would the antiderivative of 5 over x be given that rule? Not quite. Okay, there will be an ln. You both have said ln. There will be one.
5 ln x?
That's right. The 5's on the outside. You have to understand that this right here is the same thing as saying 5 times 1 over x, right? That's this constant rule right here. The constant doesn't get involved with the antiderivative. It's just multiplied by it, just like it was multiplied by the original function. And then it isn't just ln x, it's ln of the absolute value of x. Just make sure those absolute value signs are there. And then we need plus c. Make sense? Okay. Now this one looks a little bit different, and it looks a little bit different because it doesn't just have x in the denominator, right? Do you remember using u substitution last semester? Not last semester, all right, Cameron, but you remember having this thing called u substitution going on when you did integration at some point. All right. Well, we're going to be using it again, and you're going to be using it all semester. So you're going to get really, really good at it, all right? So the first thing I'm going to do is to decide what my u needs to be. And in this case, my u needs to be, in fact, the denominator. And the reason I want that u to be the denominator is because if it is, I've got 1 over u. Well, that's exactly my rule, isn't it? Sure is. Now, I'm not quite done. I need to actually go back over here when I defined what u is and decide what is du. In other words, what is the derivative of 4 minus 3x? And what is it? Negative 3. Negative 3 dx. Now, as you're taking a look at this, your problem does not have this integral of 1 over 4 minus 3x multiplied by negative 3, right? It's not there or anything like that. So I've got to do some kind of a substitution. That's why this is called u substitution. So here's the way that I deal with this, and I'm not sure how you've seen it done before, but I divide the negative 3 to the other side. So I now have negative 1/3, or division by negative 3, and this equals dx. What that allows me to do is it allows me to replace this dx with negative 1/3 du. They're equal. So I'm going to write my negative 1/3 in front because it's just a constant multiplier. It doesn't affect the antiderivative. It's just multiplied by it. And I'm going to write the du at back. That was a property of antiderivatives, or a property of integrals that you learned in Calc 1. This is really good news. That means that my antiderivative will have a negative 1/3. And then what's the antiderivative of 1 over u? Okay. The natural log of the absolute value of u. And then plus c. Am I done?
No.
Not done. I got to put the u back in. The problem started out in x. The answer has to be in x. So the answer will be negative 1/3 natural log of the absolute value of 4 minus 3x, close that absolute value, plus c.
Do we always have to show that the use substitution step?
If you're dealing with a use substitution where it's a constant multiplier like this, it's not crucial. If you're dealing with anything much more complicated, you're going to have to show it to keep track of it yourself. But that's a decent question. So, for instance, here, you're going to have to show it. All right? So, if you're taking a look at this, the only rules that you know about antiderivatives right now are the simple rules that we just did, the 12 of them or whatever, and use substitution. Which means the only thing you can look at this and say is, well, I think I better try use substitution because it doesn't look like any of my rules, right? So use substitution in this case, it would not be helpful if the numerator was u, because they still have lots of stuff in the denominator that's not going to be working with that. So your default here is going to be that you let the denominator be u. And that's actually a really good thing on this one, because if this is my u, what would du be? What's the derivative of x cubed? 3x squared. What's the derivative of 3x squared? Which happens to be the other piece. 6x. Now, and then I need a dx on the end. That does not exactly match my numerator. I need to make it. So, I think I maybe have a typo. I do, it's on my slide, but it's not on your paper, is it? Okay, so nobody's following. Did I waste my time printing these? You guys, you didn't print yours because you didn't decide not to. Okay, there's a typo on my slide, but there's not the typo on here. Kendra, is there? On problem number C, it doesn't say 2x at the top, 2x in the middle, minus 2x? It does? Yes, and my problem on here says 3. This is supposed to be a 2. The error's on my slide. The error's not on the sheet. The sheet's correct. Yeah, so let's fix that because I need it to say that. Otherwise, we're kind of in a bind. We're in a bind because if you take a look at what I just took, the derivative, 3x squared minus 6x, it needs to look an awful lot like x squared minus 2x. How can I make it look exactly like x squared minus 2x? I can take out a 3. So I'm going to actually, in essence, divide both sides by 3. So now I have 1/3 du, kind of like I did on problem B. This equals x squared minus 2x and dx. And that's exactly what I have up here, x squared minus 2x dx. That's what I'm supposed to be replacing. So I've got my 1/3 in front. I've got the integration symbol. I've got a 1 on top and a du at the back. That's all the 1/3 du part that I replaced. And I've got u in the denominator. Sound good? Okay. All right. I've got 1/3. This is exactly like the last problem at this point. ln of the absolute value of u and plus c. And exactly like the last problem, I can't leave it in u. So this will become the natural log of what? And then plus c. Good. Make sense? The thing that's challenging when you're first working with use substitution is because it requires you to use derivatives and antiderivatives simultaneously, doesn't it? And that's what makes it a little bit tricky when you first start working with it, is you have to keep in mind both sides of those rules all at the same time. So let's try this one. Because I just mentioned a moment ago that about the only rule that you've really seen much of anyway so far are the simple rules and use substitution, and this one won't work with either of them. If I let this denominator be u, and I take its derivative, I do not get anything close to what's in the numerator. Agreed? Do you have any idea of what you might try? This is a good old-fashioned algebra technique we're about to employ. Won't help. We're going to use long division. Oh, I see grimaces and shocked expressions on faces. You didn't know that you learned that for a reason in college algebra, did you? All right, so the way this works is you take the outside is the denominator. That's what you're dividing by. The numerator is what's being divided. And we're going to use polynomial division. So this is a great algebra refresher today. Algebra, algebra, algebra. All right, so I'm looking at the first value, x, and I'm looking at 2x squared. And the way that I think about this to myself is I say, what do I have to multiply x by to get 2x squared? And the answer is 2x. So I'm going to write a 2x above. And then I'm actually going to multiply. What is 2x times x? Well, that's 2x squared. That's why I chose it. And what is 2x times negative 2? Negative 4x. And then just like you learned when you did, division in 3rd grade or whatever it was, 4th grade, somewhere in there, what you need to do next is you need to actually subtract what you just multiplied. Subtraction means changing the signs. So we're going to subtract and change these signs. That's good because that means that I've got 2x squared minus 2x squared and the x squareds are gone, which is the whole point. But now I have 7x plus 4x, which is 11x. And I'm going to pull my minus 3 down as well. And I'm going to ask myself the same thing I did just a moment ago. What do I have to multiply x by to get, in this case, 11x? And the answer will be 11. So I'm going to put plus 11 up here. And I'm going to multiply. 11 times x is 11x. 11 times negative 2 is negative 22. And then just again, like I did a moment ago, I'm going to change my signs. I need to subtract what I just came up with so that the 11x's will in fact go away. And what am I left with at the end? 19. So you might think, okay, great, that was wonderful algebra, but how do I then put it back into my problem? What does it look like? Well, it looks something like this. I still have the antiderivative symbol. Instead of having this whole entire expression over x minus 2, I have the quotient that I just found, which is 2x plus 11. Plus I have the remainder, which I just found, which was 19, over the original divisor, which is x minus 2. And if you had a good college algebra course, hopefully you've seen that rewritten in that way. Without the integral signs, of course, right? That wasn't there. But everything else should look like something you've seen way back when, some day and age before. And it's really good because everything right now is integrable, and you know how to do it. What is the antiderivative of 2x? That's the derivative. X squared is the antiderivative, yeah. So we're going to go with x squared here. What is the antiderivative of positive 11? 11x. What's the antiderivative of 19 over x minus 2? The 19 doesn't affect anything, right? 19. No square roots. What was the title of the section we're in? Nobody remembers. Yeah, we're doing logs, aren't we? We've got x in the denominator. Those logs didn't go away yet, not yet. So yeah, this is a log, and it's a natural log of the absolute value. I'm totally running out of space, but the absolute value of x minus 2. And of course, I'm missing something. What am I missing? Plus c. So this would be an example, Cameron, too, kind of where you were talking of, do I need to really do u substitution? Well, technically, there's a u here. It's x minus 2. But its derivative would be 1. That's not really all that useful for showing the u substitution for. I don't really need to see that, right? So I wouldn't see that here, and I wouldn't expect that you probably would show it to me either, because it doesn't end up being very useful. So we used, and you now have, to add to your list of repertoire of things you can do with finding antiderivatives, u substitution, which you love, and now you have long division, right? Okay. So we're going to stop there for today. We will pick up with, there's one more example. It's very quick and easy. It's going to look an awful lot like the other ones we did. on part E, and then the trigonometric rules after that. So have a great couple days. 5.1 is officially assigned, which means that at the very end, or I'm sorry, not the very end, it's on a separate sheet of paper because I did it differently this time. This homework set of papers, very first line, 5.1, you should be able to do all of those. Okay? It is due Thursday if I decide to collect it. Okay?
I'm halfway done.
Gulp. So, start working on those. Come see me, go to the help center if you need help. We're here to help you, okay? And other than that, I'll see you guys on Thursday.
Fine.
I know you're taking linear. Yes.
I took Calc 1 in high school, but it was a 5-hour class.
Okay.
Then I took Calc 2 my
extra.
freshman year and
Thanks,
just didn't
Tom.
try. I got a D in it.
Okay.
So, and that was a 5-hour class too.
Gotcha.
So I'll probably know those. Or
Then
vaguely.
it should be easy for you,
Yeah.
right? But don't let that allow you to
Vaguely.
slack off because my
Well.
husband took Calc 1 his first semester of college and he got a C and he thought, I think I could do better than that. And he said,
Got a D
but I
the
don't want to
second
take
time?
it, but he didn't want to take it in. He decided to just, sit through it like a observation or whatever. So he sat through it the second time. He just stopped going in the middle. I'm like, well, what was the purpose of that? And he audited it, is what they call it. And so, yeah, don't slack off, though, because I
No,
have had
I-
students actually do that with Calc 1. I had a student in there who got a C previously. He needed to make a better
I
grade
got
than
a
a C, and he got a D
or an
next
A
time.
in Calc 1. I got a D in. It will help my GPA. I want to get an A.